Okay, so in this video we're going to look at something called percentage composition by mass. Okay, so in these calculations, essentially what you're doing is you're working out if you had a certain amount of a substance, okay, what mass of that would be due to an individual element. Okay, and there's an equation that you have to remember, okay, which is this. So percentage composition by mass is equal to the number of atoms of an element, okay, multiplied by the relative atomic mass of that particular element, and then that as a fraction of the relative molecular mass of the whole compound, okay, and then to get it to a percentage, you times it by 100. Okay, you don't get given this equation in exams very often. Okay, that is an equation that you're expected to remember. Okay, so let's do an example of one of these. So let's take the example of how much sulfur in sulfuric acid, which is H2SO4. Okay, so the thing I recommend you do before you start is as a little side calculation that you work out the relative mass. Okay, so the relative molecular mass of H2SO4 equals 2 hydrogens times by the relative mass of hydrogen, which is 1, plus the relative mass of 1 sulfur, which is 32, plus 4 times the relative mass of oxygen, which is 16. Okay, and that comes to 98. Okay, do that as a little side calculation. That will usually get you a mark within this question anyway, so it's worth doing, laying it all out so you don't miss anything. Okay, so then let's go to our equation. So percentage equals the number of atoms of an element, so the amount of sulfur that we've got in this compound. Okay, there's only 1. Okay, multiply that by the relative atomic mass of that element, sulfur, which we worked out earlier, is 32. So 1 times 32 divided by the relative molecular mass for the whole compound, which is 98. Okay, and then times it by 100 to get into a percentage. You stick that in your calculator, and that comes out as 32.7%. Okay, and that's your answer. Okay, so if you had 100 grams of sulfuric acid, H2SO4, then 32.7% of that by mass is due to the sulfur. Okay, and that's what you're working out when you do these equations. Okay, so let's try another example. Let's do how much nitrogen in, let's take something like ammonium nitrate, so NH4 NO3. Okay, so same as before. Okay, percentage equals the number of atoms of an element. So we're interested in nitrogen this time. Now I picked this one because sometimes they're not always together. Okay, so there's 1 nitrogen there and there's 1 nitrogen there. So the number of nitrogens in this molecule is 2. Okay, you look up the relative mass of nitrogen using your periodic table. Always remember to go relative mass is the top number. Okay, so it's 2 times 14. Put it in brackets just so you don't do anything daft on your calculator. Okay, and then like before, we'll do a little side calculation down the bottom. Okay, the relative molecular mass for NH4 NO3, okay, equals, there's 2 nitrogens, so 2 times the relative mass of nitrogen is 14. Okay, we've got 4 hydrogens. Okay, hydrogens have a relative mass of 1. And there are 3 oxygens. Oxygen has a relative mass of 16. So again, you plug that into your calculator and you'll get a value of 80. Okay, so the relative molecular mass of the whole compound, that's what goes on the bottom. Okay, and then we times it by 100 to get it to be a percentage. Stick that in your calculator, okay, and you'll find that comes out to 35%. Okay, so again, that tells you that in the compound ammonium nitrate, okay, 35% of it by mass is due to nitrogen. Okay, so that's percentage composition by mass. Done.